This conference will now.
I thought we've been chugging along on RTU requirements, and I thought we'd take a little bit of a breather from that uh, to discuss storage sanitization. So I don't have a lot of slides or pictures put together for this, but the the basic topic is, the hyperscaler has a bunch of user data on some storage drives and would like to decommission those storage drives. Today, one of the safest ways to do that is to make sure that those drives get crushed before they ever leave the facility, uh, because we really can't afford to have user data walking out the door. But that means, we don't have as healthy a secondhand economy. Sometimes spinning disk vendors like their magnets back, so that uh, kind of creates a gravity towards. And we've heard from this. We've heard on this time earlier this year in this body. There's a desire to say, hey, what can we do to make it so storage drives know how to keep their data encrypted at rest and securely erase it on demand. Now, some storage media doesn't lend itself towards the whole overwrite with randomness paradigm like spinning disks do. Like SSDs, they hide their capacity. But if the drive knows how to do secure crypto erase and it can do it, then life is good. Now, taking all that along with the trend of putting attestation everywhere, we want all our roots of trust to be across all these devices so we know what firmware is running. So let's say we have a storage device, and let's say it has a root of trust and it speaks SPDM because that's the trend. And we can use SPDM to attest to the version of firmware that's currently running, which is nice. But I'm wondering, is there a gap here, like a lack of tight coupling between the act of attesting that firmware is good and the act of asking the drive to do a crypto erase? Because if they're not coupled together, then there is this, time of check issue where, yeah, you might have, run one pass to make sure it's running good firmware, and then a secondary operation asks the drive to erase itself. But maybe you're not as confident that when you ask it to erase, it's actually running the good firmware that actually does the erasure. So that,
Question, please.
yes.
Aren't there separate in the sequence of time? I mean, the attestation or the attest process takes long before any of the crypto arrays or any sanitization request happens.
Right. Yes, exactly. That kind of comes down to how the particular environment wants to lash together attestation and crypto erase. But you're right. Like, if you're not purposeful about it, then attestation is a completely separate process from decommissioning drives and doing crypto erase. So you're not really, like, I don't know if you can be as confident that the crypto erase actually happened. So this
Isn't
is,
that,
sorry?
sorry to interject, isn't that up to the operator though?
It is
I'll
up to
use
the operator.
NVMe as an example,
Okay.
right? And NVMe, if you have an attest, let's assume we have an attest command added to the NVMe spec, right? You can do an attest and then you can do a sanitize. If you have not issued any intervening firmware activate commands, there's not really an opportunity modulo bugs, which wouldn't help you anyways, right? For any other firmware to have started running.
Right. You can reason about time bounds and say, oh, I attested at time 0, and then time 1 I got some non-attested signal back from the platform saying that crypto erase succeeded, and then say, well, that's close enough time together, it probably happened.
No, it's not just a time bound though.
Is it?
It's something has to happen in the interim for you to have updated the firmware, right? You have to have issued a firmware activate command.
But is
And if
that?
no such command has been issued, then there's no new firmware running. I'm sorry, I'm playing a little bit of devil's advocate, but
Oh, sure, absolutely, yeah. Please, yeah. I want to throw rocks at this. I just feel like the active now this firmware activate command, that's a management command. It doesn't have anything to do with, like, I mean, yes, the update is signed, but it's not like a privileged command that has to be signed by a central service. So someone else could have activated different firmware, right?
but who? If you're trying to sanitize a device, we're talking about the hypervisor doing it.
So I'm thinking from the perspective of I'm the control plane orchestrating the sanitization. I'm far away from the machine.
Sure, but your control plane is interacting with the hypervisor to issue these commands.
Right.
Would they
Yeah.
be
So
out of band? Like if you're on the drive, like so you're. I'm trying to understand your challenge that you're trying to make, Matt, or the point. You're saying that if the hypervisor is running, it's using the drive, and then it issues a crypto raise, and then obviously it won't remain running if it, well, maybe it does if it's in memory.
I would contend that you are not doing drive erases out of band,
Um,
because I suspect that would make your operating system very angry.
um, why is that? You're thinking that out of band is not a secure path.
It's not about security. It's about if you nuke a disk while the system's running, it's going to start to complain. Like
Well,
it has to
About
be
it being,
involved.
well, that's true no matter what path you take, right?
Sure. So if we're talking about an in-band coordinated update, you are in control. Whether you're doing it through the out-of-band path or the in-band path, it's coordinated, and you know that no other command's been issued.
Mm-hmm. Yep. So coordination needs to occur. I get that.
I guess I'm not quite understanding what the management path in here is that is causing the problem, because it seems like in the real naive sense, right? I'm sitting at a keyboard typing and I do NVMe attest and then I do NVMe sanitize and then I wait for the command to finish successfully and I can be reasonably confident that it's done and that no firmware has changed while it was running.
that does require you to have a trustworthy entity at the keyboard to make sure that happens, right?
Isn't this just kind of a variation on a state change? You know, we used way back when we were doing attestation, we talked about being able to notify the verifier, whatever that is, that the state has changed. You know, since a significant state change has happened. Because when we were doing secure boot plus attestation, we only had a point in time at boot time, and we worried about what happens later, and we need to inform something, right?
But,
That
but
um,
that's
that the
always the
change has
case
happened.
without a station lane, right? It's always a point in
Yes.
time.
So what I'm wondering is there some kind of like um, a bit string or something that would indicate what has happened, like has a write of some kind of data happened after you've done a sanitize, you know, so that when you do a test, like if you request some kind of attestation, you could examine that bit string to know that only a boot and a sanitize has happened.
In
Nothing else.
NVMe, there is. In NVMe, after pulling a sanitize, there is a bit saying that no data was written after the last sanitize.
Cool. So if you could attest to that, you would know, wouldn't you? You'd know your firmware, and you'd know that if your firmware is running properly and reporting that bit string properly, that nothing else has happened after the sanitize.
Okay, that sounds like a lighter weight version of what I was thinking of proposing. And I think that could be done with just a measurement block, which is nice. What I was thinking of that could help this situation. The fact that you need a trustworthy entity to make sure that there's no updates that happen between the attest and the erasure is to leverage, where do I have it? These vendor-defined requests in SPDM. And the thought was, what if there was a command? And by the way, vendor-defined is from the perspective of DMTF. It doesn't mean an actual vendor defines a command. It could be a standards body defined command, and those exist. But the thinking was, what if we had a command in SPDM that is a signed command, as in you provide a nonce, you get a signature back, and what it does is, it's the caller saying, please do a crypto erase, and sign a response saying that you've done it. So it's all tightly bound to attestation and identity. It's not like a two-step process, do the attestation and then do the crypto erase, or vice versa. However, if we can track, and I think, Elaine, what you're suggesting is like a dirty bit, saying like data has been written to me since my last crypto erase.
Mm-hmm.
If we can just stick that in a measurement block, then attestation work. I don't think we actually need this command. Just attest to measurements of doing the work.
Yeah, I don't think so. And if we did need a command, wouldn't it be like over in like NVMI or something to do specifically with storage devices as opposed to a generic protocol? But I agree. An attestation bit would probably achieve the goal.
Mm-hmm. Well, I mean, yeah, I think if it's like an NVMe like command to do crypto erase, it's cool as long as like it can be attested, right? And you could achieve that by tunneling it over an SPDM session, but then you have to deal with, okay, how do I create an SPDM session between my storage device and the person who cares, which would be like a remote verifier. Don't really have bindings for that. But we do for measurement blocks. So I think I like that more and more.
Hi, this is Paul Suler. I came in a couple of minutes late, and I know a lot of others have joined. What is the scope of this discussion? Is it in particular sanitization and attestation? Because there are a lot of much broader issues with sanitization.
The discussion was initially where those two areas intersect, attestation and sanitization.
I see. Okay.
And how to get a strong attestation that sanitization has occurred like you wanted it to.
Okay.
But yeah, I think the dirty bit in a measurement block solves all the problems that I'm aware of, and slots nicely into everything else that we're doing for storage or for attestation. So, what do folks think? Like, actually, this kind of blends into a different related problem, which is like SPDM is cool. It's very flexible. You can attest to whatever, but there's not really a standard format of, okay, cool, what do I attest to and what blocks do I use? It's kind of up to the device vendor to decide what's worth attesting to and to lay out their measurement blocks accordingly, and then provide manifests that point to, okay, measurement block 4 should have this hash, measurement block 10 should have that hash or number. So
Yeah, and you know what we're stepping into, Jeff, which is all of the attestations so far have been closely related to like SBOMs and what are you running and so forth. Not necessarily, I mean, there's been configuration data and stuff, but we haven't had this kind of representation of a dynamically changing state, right, of execution.
yeah,
It's a different thing. So having a manifest would be tricky, wouldn't it?
yeah. I mean, I do see, vendors attest to certain status bits, like, is debug enabled or whatever, or like what's your anti-rollback fuse setting, for example, things which, yeah, those wouldn't show up in a manifest per se. It does seem like there's a little bit of a missing bit of infrastructure there, and we're dealing with that on our end, just with internal tooling and such. but not really in a standardized way. So I guess.
So one question.
Mhm.
There's two types of manifests, right? There's measurement manifest, and then there's the reference manifest. The measurement manifest is supposed to come as part of a get measurements call, right? So a manufacturer of a device can create a measurement manifest that tells anybody using that device how the data is put together, right? For attestation responses. Is that
That
what we're talking about? On the other hand, the static manifest is something that you use to compare the attestation responses to what somebody says the attestation responses should be.
Right. I guess it's like, let's say I'm the control plane and I need to attest a device. It's gonna some of those blocks are gonna have hashes which correspond to firmware which I assigned to the device, and that firmware presumably was accompanied by a manifest from the vendor. So I have some source of truth to compare the firmware hashes to. So I know I know what, say, block 4 should be because it's a hash of this particular type of firmware. But then block 10 has a number. That number is the anti-rollback state. So how, like, as a verifier, what's my source of truth for that? It kind of has, like, right now I don't think there is a standard, and it's kind of hard to come up with one.
Well, if so, the verifiers take three inputs, right? One input is the measurements that come from the device. The second input is the reference manifest, right? And in our case, is COREM. And the third input is a set of policies from the owner.
Yeah, so it's
I
that, I think
think that anything that is dynamic state is probably controlled by policies, not by a reference manifest.
yeah, that's a good word for it, a policy. So I think it would be the policy that says dirty bit must be clear at this point in time. But
Right.
but of course, you would allow that dirty bit to be set if you're just attesting a storage device that's actually being used, because of course it has user data on it. That's what it's for. Only when you're trying to decomment and you ask it to cleanse itself would you actually change your policy to say, nope, now that dirty bit must be clear.
Yeah, or yes, you have multiple policies and you tell the guy which one to use for whatever evaluation you want from whatever verification of the data.
Mm-hmm. And
Jeff, is that just like the device has to surface like an evidence bundle?
oh yeah, that's what all the measurement blocks are, right? There's evidence.
Well, the measurements are like cryptographic hashes, not very useful for you to understand if debug is enabled or disabled unless you can somehow figure out how that measurement comprises, because it's usually compounded of several different things. There's not like, I don't know any device that dumps.
No, the measurements
And that is
are,
all in the, that is all described in the index and the measurement type value, right? The DMTF measurement type value will inform the requester as to what that measurement value is, like immutable boot ROM, mutable ROM, or mutable firmware, or hardware configuration, things like that, right? Is that what you're referring to?
No. I'm talking about like a bunch of measurements that come back from a device, not a COREM. Just a bunch of measurements that come back from a device. You need evidence, an evidence bundle on what those things actually mean.
So
that's
That
what
is
the
what I was
measurement
talking.
manifest does. That's what he just described, the measurement
Yeah,
manifest.
Okay.
not just a manifest, actual measurement values as well. They indicate what type they are as coming in from the SPDM response data.
right, like I don't think with it, like an SPDM measurement block does not have to have a hash. It can have a more transparent value.
Yeah, it
Yes.
can be hashes, it can be a raw value, right? It can be a number of things. So you should be able to represent values of variables with that.
With the variable name, so you understand it.
Yes, typically the measurement manifest, which is one of the things that device returns, should tell you that.
But you also probably need a source of truth on your end to understand if I'm attesting this kind of device, it should have told
The-
me this thing at block 4 or whatever.
For this particular, yes, and that's that. And what I was saying is, those kinds of things probably go under policy, not under the
Yes.
reference manifest, which is the core.
But the person still needs to provide a policy, right? How do you know
Yes.
that, you know, block 4 should have this value? What if block 4 doesn't have it or has something else?
Yeah, I think that's
Yeah, if block 4 doesn't have that value and the policy says it should, then the verification is going to
Where
fail.
does the policy come from? How does the device owner know that block 4 should have that value?
The policy comes from the device owner, right? So they get, there is a language called Rego. There's ways of generating policies dynamically, right? For your devices, for the different states. So somebody has to sit down and program these things,
right.
right? And that's one of the inputs that goes into the verifier.
I don't think this is very out of the box just yet. This part of the attestation.
No, this is being developed as we speak, right? In the different standards, different places.
But it's still a gap.
Yes, today it is a gap, and like we're filling it with non-standard flows in our on our side, just wired up to how our control plane understands the world.
Yeah, us too.
So let's presume that the policy situation is sorted. How would we, and let's also presume that we want to say, hey, if you're a storage device, you should be attesting to this dirty bit somewhere. It would be nice, I think, to standardize on a particular measurement block and a particular format for the contents of that block, so that vendors can just say, oh yeah, we can just say, hey, vendors, go do that thing, instead of trying to explain the principles behind it and invent the wheel every time. I'm not aware of any.
It's so specific to an NVMe device, right?
Yes, yeah, you wouldn't ask the CPU to do this because there's no such thing as a state. So,
but would it live in that? There's this giant spec in OCP. It's like an NVMe spec, or I guess an SSD spec. Would that command or that piece of evidence live over in that spec?
maybe that's a good that might be a good home for it.
So just a question, it might be, I mean, it is related. Just if you aware of the work happening in DMTF, in the SPDM working group, the storage binding.
Storage binding, you say?
Yeah. So yeah, there is an early work happening there. There is already a signed number, and that to create a work there to spell out how the format of commands need to happen. So the high level is that D10 created a security protocol ID for SPDM. But there isn't any guidance on how to use it. So some folks from T10 reach out, and we decided that this kind of work should happen in DMTF or in ESDPDM, and that how to use that ID not only for NVMe over fabric device or regular device, but also for SAS and SATA. So there's a bunch of protocols being covered there, and so I guess that's somehow related to this, and that document is in early stages, and the goal is to describe a mechanism to use the SPDM command and SPDM secure message storage protocols.
So is this like how to speak SPDM across the buses typically used by a storage device, or is this how to send management commands to a storage device over SPDM?
How to speak SPDM to a storage device.
Okay, cool. Gotcha. That sounds like a necessary part of the puzzle. We certainly need that plumbing there.
Yeah, I mean, storage device without MCTP. I mean, in a way, right? If you
Right.
have NVMe devices, if they have sideband communication mechanism and support MCTP, we already have SPDM over MCTP binding, and then MCTP over SMBus or PCI BDM binding already exists. That is not the new thing here. It is the native protocols is what Yoni is highlighting.
Okay, gotcha. Thanks both. That's helpful to understand that's happening. I think once we have those bindings in place, then we can have the SPDM signals flowing, and then that's where we would need the vendors to say to actually expose this evidence over that channel.
Well, ahead of that, wouldn't you just use it over DOE or SM bus? Like I don't know if it depends on that. Like because you can get evidence today over SM bus.
If there's an alternate path to SPDM out of band, then cool.
Yeah, and in band. Like the Linux kernel has a DOE driver.
It does, and all these exist since years now, right? All these three bindings.
Correct. Yeah.
Yeah.
I'm not an expert on this area of the stack per se.
What do you mean by it exists? It is being defined.
No, there's already, so you mentioned it a little bit earlier, but there's already a path from both out of band and in band from over PCIe and over SM bus to a
Yes, that
storage
exists.
device. There's already
That
a
exists.
path
Yes,
there that exists to get measurements.
that is correct.
So
Yes.
this command doesn't depend on really anything else, or I guess this it's not even a command, is it? This stuff in this measurement in a place doesn't really depend on anything else.
Yes, that's correct.
Right.
Yeah, so the OCP NVMe spec that you mentioned would probably be a good place for it.
Yeah, I think the type of evidence we want from different devices is kind of what needs to be put somewhere.
Mm-hmm.
Generically, all specs kind of say, hey, give us measurements, but then what measurements are important are kind of up to the manufacturer to determine. And there's no good guide out there. We all know, hey, you would want like stuff that impacts security state, and I'd classify this one as something that impacts the security state of the device. This proposal.
Mm-hmm.
But it's kind of a very generic thing to say because there's a lot of edge conditions around that. What impacts the security state is kind of sometimes threat model dependent.
Yeah, it's hard. I don't know, as a vendor, what would help here. It seems like it always needs to be kind of subjective because the vendors know what matters from the security perspective.
Yeah. I think that's why there's really been no standard. Like the closest thing is probably like TCG and UEFI because it's been so heavily defined. But everything else is there's no perfect fit.
Yeah.
But yeah, I think the NVMe spec for this, at least adding it in there to standardize it, will be good.
Are there any storage vendors on the call here who would have a problem if that started requiring you must use block, 6 and put a certain bit pattern in there if data has been written since the last sanitize. Is that problematic, too restrictive, too vague?
Maybe
Yeah,
we
You
I
mean
think
you
we can
mean
move back.
from SPDM response data?
Yeah, like set aside a particular measurement block to have a certain bit pattern that represents whether data has been written since the last sanitize.
I would not venture into that area because you already have things like global data erased flag in the NVMe response data. Why would you want to have duplicated in the SPDM response data? And how is it related to device measurements, right? The data contents are not device evidence, correct?
Yeah, so the goal would be, like, let's say I'm the remote verifier. I want to know whether the device is actually sanitized, and let's say, for the sake of argument, I don't have someone at the keyboard to run attestation and then run the NVMe commands. So I would like some kind of signed statement proving, yes, the device is running good firmware, it's running what I wanted, the measurements are clean, and also it's sanitized.
You can get that information over NVMe MI.
Okay, is that tied, like, let's say hypothetically, right, there was some awful firmware out there which would lie to me if I asked it what its current status was. Um, can I be confident that that firmware is not running when I ask it the status?
Yes. So you establish the trust, one based on the hardware identity and then the firmware measurements. If the firmware measurement reported and the actual and the reference values, if they match, then if the device lies to you, then there is a defect, right? I mean, I don't know. Yeah, I'm philosophically, what I'm highlighting is storage native protocol items. Why do we need to overload that and bring that into SPDM? That is the concern I'm highlighting.
Yeah.
Right? You
I
already have
I,
native interfaces for the exactly the thing that you're asking. Why not keep it in a native interface and keep SPDM for evidence exchange business? That is what I'm at least highlighting as a concern item.
Yeah. Oh, sorry, was there a comment?
yeah, I was probably going to add to it like that. I think keeping the business logic between SPDM and NVMe is a sane thing to do. But what Jeff is highlighting is that there's a security property that needs to be measured. And although that property is retrievable over NVMe commands, it should also exist in measurements because NVMe commands don't don't occur inside an attested session, and I don't think they ever should. But if the measurement is not signed with the correct nonce of that the device has been sanitized, you kind of get this time of check, time of use problem, and you can't securely marry a command you receive, information you receive over um, some NVMe commands with attestation. You can kind of tightly couple them with time, but it's still not sufficient to be secure.
I mean, then you get into it's a slippery slope, right? Because now you are talking about data array
Before you go
status,
down that
right?
slip,
And tomorrow, what about configuration of an NCSI device, right? And then you
100%.
have some other device.
If
Hey,
that
I did this configuration action. Did it succeed or not? I need to know that over SPDM. So then SPDM becomes a catch-all for reporting native interface state. Do you want that, right?
that's not what I'm saying. What I'm saying is anything that impacts the security state of the device. Any property that impacts the security state of the device, I'll say it again, anything that impacts the security state of the device should be reported in SPDM measurements. That's
or
it. That's it. If you
or
take
like
it out of band, you can't marry it. Or like if you get that same information over SPDM, the only thing, or over NVMe, the only thing you can do is time bound it. It's not a
So
slippery slope. It's
you
anything that impacts.
NVMe devices you have, even you highlighted sanitize, right? Okay, I understand sanitize, and again there are three types of sanitize operations. Then you may have an SCD, which may implement a TCG protocol like an Opal or something, and then that state is, you have configured, taken ownership of, set up the locking bands, or erased it, or cleared it. Then how expansive you want to go and define that security state to be, that gets that's the complication, right?
Of course, yeah. And that's what I mentioned earlier is there's no standard that defines what is and what is not security state.
Yeah.
And what we're saying is, we can start to define that with things like this.
Okay.
the other alternative, like instead of having SPDM surface knowledge about this, like we could, it's a lot of work, right? But you could find a way to tunnel NVMe commands over an SPDM session and then just get all the bindings you need to expose that signal to the remote verifier who cares. Like a lot of work.
Then you need that end-to-end secure session, right?
Yep. So
Yeah.
bindings which don't exist. So it does seem simpler from the end-to-end security state to like, hey, we already need to surface SPDM measurements wherever they need to go to the remote verifier or whoever. So if these security indicators can ride along with those measurements, I think that's less work overall. Although, I do see, there is potential for more things to be relevant.
It probably would be a good specification to have like a list of common security properties that should be attestable, and then have like this one more device specific ones. Like a general guide, because it's one of the things we see gets overlooked a lot is attesting certain properties that greatly impact the attestation of a device.
I'm just gonna start a doc with that real quick to make sure that doesn't get lost, because I think that's a good idea.
Brian, we're working on the BMC document. What would you say in the BMC case are things that should be captured for the security state of the BMC?
Yeah, that's a really good one. We could have a short list of things that I could send you that I think would be good to have from a BMC security perspective.
All right.
Obviously, the full firmware stack and software as well.
Yeah, right.
But the configuration of the device, and a lot of it is done sometimes blown with fuses. BMCs are a special class of device, but
yeah, so state of the fuses. All right, well, I'll look for email then. Plug that in. If anybody else has ideas, send them or put them on the reflector, please.
So Brian and Jeff, if we do define a measurement block that has some bits to indicate that there was a write after a sanitize, this implies that all these NVMe devices, they must support fresh measurements, right?
Yes. Are you referring to the SPDM capability?
Yes. So what I'm trying to say is that okay, from a device point of view, NVMe device point of view, I think if we were going to define a bit in the OCP and NVMe SSD spec to indicate this, a write after a sanitize, I think what Brian was suggesting, I think it's a good idea to indicate that in measurement blocks. But this requires that the device, report, a fresh measurements, right, every time, right? And so it's an indirect requirement for all these devices, right? So
Yeah. So just to be clear, like nonces are always part of the protocol, regardless of when the measurements were computed. So this is just discussing when were the measurements computed. They could have been computed, on boot time and then ignored. But what you're pointing out is like, no, you actually need to compute these things on the fly if you want.
Exactly.
Yeah.
So it requires also that the NVMe device support fresh measurements, right? Otherwise, this would not work, right?
Yes. Although, I mean,
would resetting the device not be a way to avoid having to do this? If the measurement gets put into a certificate or something, or on boot of the device?
that would be a way to do it, to say, do crypto erase, don't bother attesting because it's stale, reset, and then go do a test. So you could do that.
It's a little clunky, but
yeah, exactly. And I think, is there a concern with implementing fresh measurements? Is that difficult as a vendor?
Yeah, I've heard that for some devices, it's challenging, right? Some of the measurements, may not exist, right, all the time, right? Especially if you have many layers of loaders and so on, right?
Now, if the measurements are not fresh, they would be cached, right? You'd
Yes.
say, for example, measure firmware at boot time, cache that measurement, and then report it as a block whenever, right?
Yes,
So
but
I think, let's see, what is it? If measure first 0, responder supports recomputing all measurements that require reset and shall always return. Okay, yeah.
For things like firmware, this gets really difficult because you end up needing to have some separate entity that can do the measurements, so that way it's not the firmware measuring itself, right? And then potentially lying.
Yeah. So I think what we want really, like, I don't think we want like measurement, like what firmware booted, like what did I measure at boot time? I don't think we want that to be fresh. That should remain cached because that's a reflection of what was happening when the device booted, right? But we do want other blocks to be fresh, right? Like this dirty bit, for example. So I'm looking at this language here, and I'm seeing if this is 0, what that means is, as part of the response message, the responder may return measurements that were computed during the last responder's reset. This is not saying they are all cached. It says some of them may be cached. One says, shall always return fresh measurements as part of measurements response message. So it seems like if you have some measurements which are cached, because that's what we want security-wise, and some that are more freshly computed because that's also what we want security-wise, then 0 is what this should be.
It seems that maybe you want that attribute per block, do you?
Yeah, that would be nice.
So I think it's a per measurement block, or I think it's a per measurement block thing.
Well, this is this
capabilities?
No, this is a capability, right,
yeah,
for the device.
Capabilities. Yeah, this is like global state. So I think it's a bit.
But essentially, what you're looking for is on a get measurement request basis for a given index or a given measurement block. You are asking that be either fresh or previously calculated.
Yeah. I think I don't want to like impact. I don't think we should start mandating that firmware measurements get recalculated on the fly just because we want a fresh dirty bit. And it seems like if we're going to do that, have some be fresh and some be cached, then we simply just leave this as 0 and call it a day.
Yeah, but if a device reports 0, how do you know that the measurement of that bit is fresh? You don't know that, right?
Well, I think you always need to. I mean, I think your policy and manifest should be having a source of truth over what's in the blocks, where they are, and what they mean. The device could advertise, "Hey, I configured this freshly" or not, but you always need to compare that to a source of truth that's not the device.
This is a weird bit, I
I'd
think.
agree. I
in the
agree.
spec. Yeah. Like you always
Al-
want
al-
attestation to return the current state of the device, the current security state of the device, not like if the device boot, that includes events that happen in the past, but they don't get those events don't get recalculated. They're stored and cached. But then there are runtime security events like you booted with debug disabled and somehow it got enabled and the device is still running. You can reflect that boot measurement, but it's more important to reflect that, hey, debug is now enabled on the device. Same with this bit. It's going to be runtime enabled. You want to report the honest actual state of the device at the time of attestation. And that might include past events, like you had a device booted on bootloader version A, but it's currently running version B. You'd want to know that for attestation.
Again, I think the primary problem with this fresh measurement thing is that the primary thing that most people are focused on right now is around measurement of the actual firmware that is currently running, and that's difficult to do without having the firmware just measure itself in a lot of devices. If we're instead talking, like, it's almost like we need to have this capability be unique per measurement type and kind of differentiate between measurement of firmware versus measurement of current security state.
Yeah. I mean, I think if you're ever at the point where SPDM is reporting a measurement of its own firmware, then that's informative only, and you really should be using DICE.
Yeah.
Also,
If the
why
device
did
supports
you,
DICE.
Brian, maybe could you elaborate why did you, so I think Chandra mentioned that there is similar capabilities that what we are looking for through NVMe MI. Why could we not run NVMe MI commands over a SPDM secured session?
The reason, and that would work, like, from a security principles perspective. The problem is just that it's like that infrastructure doesn't exist really. Like the bindings, like you need to tunnel SPDM over some management protocol like Redfish, although that would be not good. Redfish is not a suitable protocol for tunneling an SPDM secure session over. So reach for something else, and then just make sure that you can tunnel your NVMe commands all the way to your remote verifier. Because, like, we're not talking about two components on the motherboard trying to test each other or talk over those wires. We're talking about there's a remote verifier who wants an attestation that erase has happened. So it's just a lot more legwork to define how all that works together.
I see. Thanks.
So as far as fresh cap goes, yeah, I do think it's interestingly defined, and I think the way it is currently defined, just leaving it as 0, doesn't violate the spec. Cool. Well, I think there's a couple of items of work out of this. One is to go rummage through the NVMe spec and see what can be added there as far as some security state bits. And we could be more general than just dirty bit, maybe leave room for others instead of defining a new block for every different piece of debug state we might think of. And of course, we want to be judicious about it. Like, we don't think we want to like duplicate all of the status surface of a storage device in SPDM. We just want to pick the ones that are security relevant. And then also we can, let's see, I have just tossed together this thing real quick. It's totally blank, but it's a doc. It's in the OCP drive and it's public, so we can put some stuff in there about here's some rough things you should attest to on a general basis and maybe on a per device basis or per device class basis. So BMC stuff could go in here, storage device stuff could go in here.
Cool. Yeah, that'd be great.
Okay, cool. Well, I think that's a natural wrap up at this point.
Is there a timeline for working on this?
I don't know. I mean, like, I haven't defined one yet. No. Is there a reason to be fast or slow with this?
No, it was just a curiosity question partly, and then the other part is, as we look at if there is any new requirements, right, out of OCP, I just want to make sure that we have line of sight for that as we are defining 1.4 on SPDM. That's the main.
Okay, I see. Yes. It would be interesting to see if we can clean up that fresh measurements concept, but I mean, it doesn't seem very like critical for us. I think it's a bit confusing, but it's kind of just curiosity.
Okay.
There was, oh, you know what? I don't know if this would be the current way SPDM emits signatures is a little bit awkward to expose off machine, because what you sign is not your measurements. What you sign is a transcript of a conversation where the measurements are exchanged with the requester. So to emit a signature over all that a verifier can comprehend requires that you sign the entire transcript. I think there was a talk at the OCP Regional Summit about this that I gave. So it could be interesting if 1.4 defined a more ergonomic signature format. It's just sign me the measurements so I can stick that in a struct and send it out over something that's less chatty than just trying to parse a transcript.
Yeah, like a simple measurement quote command that doesn't even require a secure session.
Exactly.
Yeah, much needed. The whole the other transcript piece is really for that key agreement and session establishment. All of that's not needed for attestation.
Exactly. Yeah. And actually, yeah. So that will require some legwork, I think, to get that through. But it certainly is. I think there's some appetite there for that. Kendra, sorry.
No, I said got it. Yeah.
Can you what? I know 1.3 just got dropped, right? What's is 1.4 in the requirements gathering phase, or did we is it pretty full up? Like they already know what they want to work on?
No, it is in the early stages of requirement gathering, and
Okay.
I'm thinking for the next few months we'll be in the requirement gathering phase for 1.4.
Okay, cool. So yeah, I think last time we brought this up, it was pretty late, so it was hard to get it in, but this might be a good time.
Yeah, at least till the end of the year, I anticipate 1.4 will be more like requirement gathering, assessment of hey, what can be done, what is required by the industry type of phase, and then get into development probably towards end of the year or early next year.
Okay, cool.
Again, I mean that's my my
Sure, sure.
interpretation. Obviously the work group chairs decide the pace and the agenda.
Yeah, non-binding. Gotcha.
Yeah.
Cool. Thanks for that update. All right. So cool. And I think that is orthogonal to this, what we've been talking about in this call about having a new block, because that block will either show up in a regular transcript signature or signed transcript, or newfangled quote if we can get that in. Okay, cool. Thanks everyone. Good conversation. Catch you next week.